We're going to start this week out just reviewing how to summarize Q to Q back from chapter 5. So this is a video just walking through a basic example. We have an XY chart with data values with no context here. And we're going to start with, well, here, I'll let you, if you want to pause it right now and take a look at this whole document, you can. We're going to start with just getting the summaries, slope, y-intercept, and the regression equation from the prism. So in the calculator, you can see I have in list 1 the x values, in list 2 all the y values. Now there's two different ways to do this. First, we can hit graph and make sure one of them is set to scatter plot. I have my graph 1 set to scatter plot right now. So we're going to press graph 1 and we can see the scatter plot. You can see this 1 sticking out, this very unique value. How it was going down, 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 jumps up, comes back down, continues on. From here we can calculate, and this is linear, it has to be linear for us to do this, x, and we use a plus bx. And you can see our equation, our slope, our correlation value, all that good stuff. We can also draw our regression line. You can see it passing through. Most of these values seem to be okay. I don't think we're going to have any outliers. But the other way to approach this is just if you don't need to see the scatter plot, you just want to calculate it, calculate regression x. A plus bx. I am going to show you one other way to get this, but we'll do that in a moment. So we're going to start with our slope. Remember, the A is the y-intercept. B is the slope here for us in statistics, the way that we write it. So there's my y-intercept, 100.32. So we'll go ahead and fill that one in, 100.32. And our notation for that is b sub o, lowercase b sub o. Remember your notations through all of this. And my slope is negative 1.6. So I'm going to go negative 1.6 is b sub 1, and that is slope. And so my regression equation, it's not y, we use y hat, and that's for the predicted values. Y hat equals 100.32 minus 1.6x is how we write the regression line. Now what we're going to do in this chapter coming up is we are going to be making several predictions, several tests. One of them is we're going to be testing about slope to see if there's a relationship between two variables based on what's happening with the slope. We'll start with that. We're also going to be studying the residuals. We're also going to be studying predictions and how far off our predictions might be. Many layers to this because, you know, in a scatter plot we have lots of different things going on. Next, we're going to find typical residual size. Now, the typical residual size can be done in several different ways. First of all, remember that the residuals are in list 3. Unless you changed your setting, your residuals should all be set up in list 3. So all of these right here are going to be my residuals. And I can calculate all of those by hand. I simply would take the residuals, which is the actual minus predicted. So I would have the y values minus y hat, and I would square those. So all the residuals, these represent the residuals, and I would square the residuals. And I would take the summation of all those squares, and then divide the whole thing by n minus 2. And then take the square root. And we can do that on the prism. I have all my residuals here, and if I want to go over to list 4 and tell it to take the residuals and square them, so I would type in shift 1 to bring up the word list, and I want it to square list 3, so list 3 squared. Now list 4 will be all the residuals squared. And I'm going to take the sum of that, and we can do that in here also. If I go into option, list again, option list, and then inside F6 a couple of times over we go to sum, and then I can take the sum of list 4. So we're going to hit shift list 4, and the sum is 236.33. So that whole sum is 236.33, and there are, I believe, 11 values here, 5, 10, 11, so n minus 2 would be 9, and we take the square root of that. And we can run that calculation. We can even do it inside of here. Take 236.33 and divide it by 9, and then take the square root of that number, shift here, 26.258. And this is the way we found typical residual size, which is about 5.12 in the past. So there's our typical residual size. Now, I'm going to show you another way to get all of this information very easily. Of course, there's always shortcuts. I think one or two of you figured this out earlier in the year. But if I go into test, and we're going to be using this test in probably the beginning of next week, maybe later this week, and I hit test T, and then I go to regression. So again, let me go back and show it again. Test T, regression, and then we'll run a regression test. Now don't worry about the test results right now, we'll talk about that later. But when I run a test using my two lists, list 1 and list 2, it gives me the t-score and the p-value and all that stuff, but I'm not interested in that. Look what it gives me. It gives me my y-intercept, my slope, it gives me r still and r squared, but it gives me 5.12 SE. SE is the typical residual size. So again, one more time, just run through that. If I just run a test, I'm not worried about the test results, and it's T and regression, and I run that test, it gives me the summary that I needed for the first question plus the typical residual size all on the calculator. So remember, typical residual size tells us how far off we expect a point to be. We'll get back to that in just one moment. We'll do a little more notation here. Let's start with typical residual size is S. Even though on the calculator it's SE, the notation is just S. We'll talk about population. Since that's our goal, we're going to make inferences about the population slope and about parts of the population. So this would be the y-intercept of the population. That's denoted as beta, capital B, the Greek letter kind of a thing, sub O, and beta sub 1 would be the slope, which is negative 1.5. So let's say this was the actual population. This is just what my sample would predict the equation to be. This is the actual population. And what is this equal to? It's not just y. We often denote this as mu sub y. And you'll see that pop up, although you really don't have to use that much. Last part, we're going to take a look at predictions. What does the prediction tell us? If x is 21, what value would our regression line predict? So I can just plug 21 in for x and run that calculation. Or when I have this from any of the screens that I've shown you where we've calculated the equation, you can hit copy, and you can copy that and make sure you hit execute. So we hit copy, and you have to hit execute. And then when I go, and I like using the table app, so I'm going to go to app 7, the table app. You can see it's in there. I got all this other stuff in here. So let me highlight the equation I just put in. You see the equal sign is now highlighted. And when I go into the table, I'm going to put in 21 for x, and I get 6.67. So the predicted value, which is down here for y, would be that y hat is the predicted value is 66.67. Now that's what I predicted. What did I actually get? What I actually got was 74. Okay, so how far off are we? Would you say that this value would be unusual? Is this what we're predicting too far off from what we got? Is this value of 74 unusually high? We saw it on the scatter plot. It was quite a bit above the line, but is it unusual? Well, that's based off the typical residual size. So we need to find this residual first. The residual is actual minus predicted. So the actual score was 74. That's straight from my sample. And then I subtract the predicted, 66.67. And what I end up with is 7.33. So this is 7.33. That's a little high. Is it unusual? Well, it's a little bit higher based off the typical residual size, but is that unusual? And well, that's what we're going to be testing, part of what we're going to be testing in this chapter. Maybe slightly unusual. It's certainly not 2 standard deviations away. If we're treating this like our standard deviation, it's certainly not 2 standard deviations away. So I don't know if this would be very unusual, maybe somewhat, possibly, but again, we'll explore that more in this chapter. One last thing that I want to take a look at is just a review about R. We'll run the calculation one more time. And our R value here is negative 0.935. That is a negative correlation. It's pretty strong. So it is a very strong negative correlation. R squared, 8.87. That means 87% of the response variation can be explained by this regression line, which again is pretty strong correlation.